Hey, this is Josh from LeetDev, where we explain programming questions as simple and concise as we can. Today, we'll be talking about the problem Binary Tree Inorder Traversal. It's what I consider one of the basic tree traversal algorithms, so we'll be talking about it and the other variations of tree traversal that's available. Given the root of a binary tree, we want to return the in-order traversal of its node value. Now that's not very helpful, it doesn't tell us how that works, but if we look at example 1, notice that our output is 132. Specifically, we travel this node, 1, then we get 3, and then 2. In example 2, we have an empty node, so our output is empty. Example 3 is nothing interesting. Example 4, it's interesting that note that we print out our 2 first, and then our 1. But then if we have another example where we have 1 and 2, but 2 is on the right subtree, we print out 1 and 2. We're going to talk more about this on the whiteboard. There are 3 types of traversals that we can do in a binary tree: a pre-order, in-order, and post-order traversal. We'll talk about all 3 of them. However, the idea with these traversals is mostly how we process the tree nodes that we're at and then traverse it. So in pre-order, we process first, then we traverse our left node, and then we go our right node. In order, we would go to our left node first, process the node, and then we go to our right node after we're done. And then finally, in our post order, we would traverse all of our left nodes, then we would traverse all of our right nodes, and then we would process the node. My favorite strategy to figure out the node that we're processing is to draw an arrow. For a pre-order, I would draw an arrow facing the left side of the node. For in-order, I would draw an arrow facing the bottom. And then for the post-order, I would draw an arrow facing the right side. Now I'll show you what they're for. So imagine for a pre-order traversal, we would start from the left side of our node, and then we just wrap around the node and print out every value that we encountered first, that the arrow is pointing to. So pre-order, we encounter 1. Then we go and encounter 2. And then we wrap around the 2, past the 1, and then we hit 3. And then we complete our loop. And that is a pre-order traversal. Now, to do an in-order traversal, we would do the exact same thing, and we print whenever our arrow points to a node. So we start on the left side, we wrap around our tree. Notice how we don't print out 1 yet. And then we hit the bottom of 2. So we encounter our first node, 2. And then we continue along, and then we hit 1. And then we hit 3, and then we finish. Finally, we have our post-order traversal. Like always, we start on the left side, we wrap around the tree, we hit 2, wrap around, hit 3, and then we hit 1. And so that gives us the order 2, 3, 1. And now that's roughly how you would do a traversal. To start off, I already did some administrative work for us. I defined a list that we use to store all the node value that we will encounter in an in-order traversal. To traverse all trees, we use recursion. And so we define a helper function that passes in the root and the list. And then after we finish recursing, we just return our list. Now inside our helper function, for all recursive problems, we usually have 2 things we need to find: our base case and our recursive case. In this instance, our base case is when our node is null, but we don't really do anything when it's null, so we're just going to say if our node is not null, and then we lead up to our recursive case. For an in-order traversal, we do 3 things. We traverse the left subtree of our current node, and after that's done, we process our node, and then after that, we traverse the right subtree of our node. And that's all we have to do for this problem. Now let's go to the whiteboard and walk through this. So we start off with our root node. We're at 1. We enter our recursive helper function with our 1, and 1 is not null, So we first go to our left node. It is also not null, so we go to its left node, which is null. And when that happens, we just don't process anything, and then we recurse back up. Now, after we finish recursing our left subtree, we process our node. And so we add that to our list. And now we have the answer 2. And then we go into its right subtree, which is empty, so we don't do anything. So we recurse back up and then go back up to 1. Now 1, we have processed our left subtree, so now we need to add its value into our list. So 1. And then we need to explore its right subtree, and then we end up at 3. This node is not null, so we traverse to its left, which is null, process it, traverse to the right, which is null, then we return back up, and then we go back up to the root node, and then we finish going through our helper function. And after that, we just return our list, and then we're done. Now let's quickly submit our code. And there we go. This is how we would do an in-order traversal of a binary tree. If you have any questions, please leave them in the comment section below. Otherwise, if you found this video helpful, consider hitting the like button and maybe even subscribing to get daily updates. Otherwise, I'll catch you in the next video and have a great day.